Yeah, my name is Oliver. I'm a security engineering manager at Uber. My team focuses on cloud security for Uber. Like I said before joining Uber about 2 months ago, I worked for Microsoft about 18 years, mostly on the Windows operating system and Office Online. I did development, testing, mostly security, program management, and over the past, I would say, year or so, I looked intensively at the security for the continuous delivery pipeline and the build system and our engineering systems. And what we found was kind of scary in a way, and that's why I felt this might be an interesting talk. I want to look at the continuous delivery pipeline. What does it mean to have a pipeline and to deliver continuously? Look at some existing and attacks that happened in the past, in the recent past. Look at open source. How do we consume it and how can we make sure it's secure and trustworthy? And then also discuss some of the key takeaways, and hopefully we have time for questions. So let's do a quick show of hands. Who's doing continuous delivery right now? Yeah, quite a few. What does it mean, continuous delivery, the CD? It's not a Windows receiver. So continuous delivery means you can deploy at any given time, right? And basically to do this, you have to automate the pipeline, which means your testing, right? Your release management and your deployment. Everything should be automated and you should be able to deploy at any time. Doesn't mean you have to deploy at any time. In some cases it makes sense, like Facebook, they deploy every hour. They deploy the core of Facebook every hour. But if you're working on, let's say, security updates for Windows, it doesn't make sense to deploy every hour, right? You want to deploy maybe every other week or so. So why is it hard in terms of security? But if you deliver every hour and if you constantly build and constantly put stuff into production. Again. But anyway, so it's hard, of course, because you don't really know what the data is that you're shipping, right? Or it's very difficult to find out. You have to rely on your change management, maybe your Jira database, right? And you have to have a good understanding of what is your shipping. And also, you don't have much time to do security testing or penetration testing. Right? If you ship every hour, you can spend 45 minutes doing penetration testing. But if we look back at Windows XP and Office products, we would ship every other year. And then it's okay to say, let's spend 2 weeks just looking at security and looking at the threat models and doing security testing, and that's fine. Right? But if you ship every hour, you have to be very smart and you have to automate your security testing and validation. If you have a lot of automated tests, right, and you should if you're doing things like test-driven development and you automate the unit tests, integration tests, and you release frequently, it's also difficult to decide how much testing is enough. Do I need to run every single test every time I make an update, or can I be smart about selecting the right tests? And when do you have enough confidence to say this is it's functioning and it's secure? So the key is really you try to automate this validation and to make it part of every single step in the pipeline, in the cycle. Right? You start with your IDE or your development environment. And ideally, you do things like static code analysis all the time, right? Before you check in, maybe it's part of your pull request, maybe it's part of your build policy, right? You do code analysis, and if there's a security issue, you cannot build, right? You maybe stop or you have to fix it, or at least you get a warning. And again, these are policies that you might be able to define in your team and say, look, we are very strict about this, and we don't allow anything with known security warnings to go into production. You might do something like style checks in your dev environment where you basically get warnings while you're coding. That's kind of nice, right? And once you do integration, you could also look for things like open source usage. We talked about Docker images, right? Scanning Docker images. You can do the same for your builds and scan everything that's being pulled into the build and see, am I putting in any packages that have known vulnerabilities in their code? Unit testing is important, but if you do just unit testing, you tend to focus on the heavy part tests, right, and just make sure everything is working. If you look at security, you also want to test the boundaries to make sure that I can't go beyond this boundary, or if I try to access this, I should be denied. And these are tests you also want to automate and make part of your unit integration tests. So don't just look at the function, but also look at security and make sure the right measures are in place. So typically, if you deploy as part of CI/CD, you might have a staged deployment, right? You deploy to maybe a development environment where you do some additional testing. You might deploy to a more advanced int environment or test environment that you expose maybe to a subset of your customers. And then once you get good feedback and good telemetry, you go into production. And again, this can also be automated, that you collect telemetry, and based on telemetry, the system decides whether to go to the next stage or not. As part of this, you can scan your infrastructure. And everything that you put in production, we talked about bloated Docker images, right? You scan everything that you put in production, and you measure what we call the attack surface. Right? Everything that you put out there, a new database, a new package, a new API, increases the attack surface. And what you should do is you measure it, or you scan it, you record the attack surface, and you see, is anything that changed between two builds, and did I increase the attack surface without knowing maybe? Ideally, you have more automated tests, not just unit tests. A lot of teams that I work with don't. They just do unit testing, and then they hope for the best, right? And they collect telemetry and hope nothing bad happens and move to the next stage. But ideally, you should have automated performance tests, integration tests, and also try to stress the system maybe and look for ways to get into the system. Do the same for every single environment, right? You check your test environment. Also, you want to make sure that it's consistent with your production environment and it's got the same attack surface. We heard previously that sometimes we put a lot of stuff in dev that shouldn't be in production, and again, that makes it very difficult to test and validate. So you should treat everything like a production environment. And then finally, once you're out, you want to keep monitoring your system, right? Look for things that are happening, look for telemetry that's looking bad, look for maybe intrusion activity that's happening, and then be able to maybe even roll back a release and say, look, it doesn't look good, let's automatically go back to the previous version. Right? And that's very advanced. If you have automated rollbacks, right, you basically go to production and you collect telemetry, and based on the data you get back, you can eliminate the decision-making process, right? And just say, based on the data, the system is smart enough to roll back to the previous version and fix it that way. So that's what a build system might have looked like, 10 years ago, and in some cases it still does, right? You have your build machine, or your build server, right? Your source code is maybe on a file server, maybe it's on premises, it's on a machine somewhere. And it's quite easy, right? You get your source code, your build, you get the output, and then you release it. And releasing could be a guy using FTP to copy it somewhere, but it could be more advanced. It could be you're burning a disk and give it to a customer. This is quite easy, and if the source code is kind of protected on-premise, then it's relatively easy to protect. But these days it looks more like this, right? You have your build system, and then you probably have your code on GitHub, right? You might have Bitbucket, or you might use the content from a content delivery network, right? You might have some documents that you put into your build, and other resources like I've seen pastebin.com being put in, right? That's not recommended, by the way. You get your output, and then you have maybe a release service or release management system that does all the stage deployment and validation and configurates. And deploying could be that you use the Docker container, right, or a VM. The point of this is you have to protect and worry about all of these now. Right? We learned about Docker, but the same goes for VMs. Right? If the VM is uncached and it's stale, then right, you're exposed to security vulnerabilities. This is what automated scanning basically looks like. Right? You scan your environment, your virtual machines, your maybe databases, web applications, containers, and other resources, which could be data lake jobs or machine learning jobs, anything you put out into production, and you get an inventory of everything you got there, and then you compare it to what you expect to be there, the whitelist, right? And if there's something that's not matching, you can file a bug, right? But you should probably also stop your deployment at that point. But you shouldn't say, well, I filed a bug and check it in 2 weeks, and I want to go out now, right? So this sounds scary, but do people actually attack this what we call supply chain? And the answer is yes, they do, right? And that's even scarier. So there's one attack actually very recent, ESLint. Does anybody use ESLint? Or, yeah, very popular. Oh, yeah. And the irony is it's there to find issues in your code. Right? What happened was this. Apparently a guy who maintains the code base for ESLint and was a bit lazy with password management and used very weak passwords, and they used them everywhere. Always the same password, and somebody found the password and used it to basically inject code into the ESLint repository. And they published a managed version of ESLint scope, right? And that's kind of scary, right? Because now they can basically put everything they want into every build that's using ESLint, and you wouldn't even know, right? And the code actually did nothing but just download malicious code from casespin.com. The good news is, or the funny thing is, the code that they put in had a syntax error. It didn't really work. I don't know why they didn't test it. Probably wasn't the government agency. But it is scary, right? I mean, if they would have succeeded, they could have infected any product using ESLint and you wouldn't even know it. Right? So they kind of failed. But then there was another attack which didn't fail, and this was CCleaner. Anybody know what CCleaner is, or is anybody using CCleaner? Yeah. Again, very popular, and it's meant to basically clean the system and eliminate and reduce the attack surface and make it more robust. And it's very similar. The attackers, and in that case, it was a government agency, they got into the build system again. They didn't get into the source code, but they were able to get in between the build and the code signing. Right? So they could add malicious code to the binary before it got signed and packed together in the installer and put onto the download server. This means about 20 million users, they downloaded CCleaner. Right? And it was not a spoof website, it was CCleaner, right? And it was signed correctly, the certificate was okay, everything was fine, right? But it contained malicious code. And the code was actually, it was setting up a botnet, it was looking for basically usage patterns. And it actually contained a wide list of domains it was monitoring. One of them was Microsoft, but there were other government agencies and domains that were interested in just spying on. So they succeeded and they infected about 20 million clients. And I'm sure there's still some out there that are not patched. So I want to briefly talk about open source. We all love open source, and Microsoft does as well, and they use it a lot. And, that's true. Right? And we should all be using it, and it's obviously, I mean, you can't really live without it these days, but you also have to look at the project that you want to take a dependency on, maybe, and look for the metrics in, for example, GitHub and see, is this an active project, right? Is there a lot of traffic? Do they get views? Do they get pull requests? Do they fix bugs? Or is it a dead project, right? I've seen projects that have been touched in 5 years and then suddenly somebody fixes a dependency. And that's kind of risky, right? Because what if something goes wrong? Nobody's going to fix the code for you. Right? And sometimes you have to go in and fix it yourself. One relevant example is Ruby gems. It's again very popular. And this was a vulnerability in the parsing of YAML files. Right? So in Ruby gem, you can use YAML files to build objects, right? And you can also use it to build malicious objects and inject code and execute it on the application, right? And this is what really happened. So these attackers, they were able to create malformed YAML files that would execute code on an application built with Ruby gems, and that accept the YAML file. This is a bit old, but I'm sure there's still applications out there that are open to this. Maybe the most famous attack was Equifax. This was last year. Kind of similar. It was a vulnerability in Apache Struts, and it was again a file upload, right? The file contained the content type tag, and you could put code into the content type tag. They didn't validate it. They didn't check it. Very easy to patch and to fix. Right? It was found in January and I think patched the same month, and there was also instructions how to do it yourself, right? How to just do the validation in your code. I guess the embarrassing thing was really Equifax. I guess they didn't scan the code, like a lot of companies don't scan it, and they were exploited and attacked in June. That's almost half a year later. And the attackers, they executed code on the machine that was taking the file and basically just did a database dump. Right? And they got customer data for 117 million customers, and that's very, very sensitive data. Equifax does credit scores, and it's really sensitive data, and it was a big financial loss, but also a PR loss for the company. Right? And this could be prevented by just looking at the code they're putting in and doing a scan and seeing is there a vulnerability, and also is there a patch for this available. So how do we use open source? Right? There are many different ways. You can use packages like npm, UGit, Maven, right? And that's the recommended way, right? You put in a package, but also you put it in from a trusted source. Right? Like UGit.org, you don't put it in from some file share in Russia. Right? And that's also, that's happening. Right? People just say, oh, I found this, I Googled for this package and I found the location here and I was taking dependency. Right? Just because somebody says, I'm Angular 4.0 doesn't mean they are Angular 4.0. Right? I've also seen teams just copying the code into the project, right? And that's not really recommended, because what if the project is patched? Right now you basically have your own little fork, and but it can not be patched, or you have to do it yourself, and that's almost impossible to manage. Right? Also, some teams they build and just copy the binary into the source code. It's the same thing, right? It's not recommended. And, your scanners wouldn't find it, and you wouldn't be able to catch it. Right? But sometimes we also may use a script tag rather than just put in source code. And again, it should be a trusted location. Some companies, they set up their own CDN for this, where they copy the trusted packages. It's also for reliability reasons. But what if the site that you're putting from is down, right? And suddenly your application kind of looks ugly or doesn't work anymore. So recommendations, you have to check for these CVEs, right? They're CVE databases, they're not super easy to use, but you can search for vulnerabilities, and it's automated, right? There are a lot of tools to automate this, maybe as part of your pull request or as part of your build, right? And you basically look at everything that's being pulled in, and you do a comparison with CVEs, and then if there's something that's critical, you might just stop the build, right? In most cases, you find instructions on these CVE pages how to patch it. It's typically just getting a newer version, but sometimes, sometimes not that easy. You have to work around this and either find alternatives or fix it yourself. It's open source. Right? So make sure you can actually trust the source of the packages. Right? Don't just any file share somebody wants to do. Don't use binaries or just the code. And also, again, look at maybe GitHub and see, is this really an active project? And are bugs being fixed actually for this project? And if so, how long does it take? And does it look healthy, or is it something that kind of looks sketchy or almost dead? Are we on time? So the key takeaway is really look at security holistically, right? Not just for your application, right? And that's what I think that's the mistake a lot of companies and teams are making. They look at securing the application, but they don't look at the build system, for example, or the infrastructure behind it, right? And just because the application might be secure doesn't mean that the application that you build actually is the one that you thought you were building. And that's a scary thought, but you have to really look at the entire system, right? The pipeline, the build system, and everything that you take your depends on that you're putting into your product. Automate the validation, right? It's unit testing, it's integration testing, OSS scanning, checking for patches of your VMs, right? There's tools to automate penetration testing, right? There's ZAP, the tool that's open source, and you can use it to scan your environment, to do passive penetration tests, and make all of this part of your delivery pipeline. We didn't really talk about this, but just don't store secrets in source code. And that's, I mean, we all know this, but it's actually very common, right? And what happens is people, they want to test something, they write a connection string, they put in a server name, password, and suddenly it's on GitHub, right? And people can see it, and they can use it to connect to anything. And that's actually very common. That and there are tools that scan for passwords and secrets in GitHub, right? And that's scary, right? Because that's what attackers are using. They can scan thousands of repositories, and if they find one or two, then they're in, right? So don't put your secrets in there. And also, I mean, look at security at every stage of your development lifecycle, right? Not just as an afterthought. Like, don't just build an application or service and then say, I'm done now, so now let's look at security and your penetration test. But really think about security when you design your application, right? When you're coding it, right? Even in coding it, you should do good analysis, you should be doing all the right things, and you should have good automated tests that do the basic security validation for you. One thing about this delivery, right? It's really hard to say at what point do you want to reevaluate the security architecture. But again, if you think about Windows and Office, it's easy. You do it every single version, right? And that's every 2 years or so. It's easy. But if you ship every hour, right? Do you wait 2 weeks? Do you wait a year? Do you look for certain changes in the application that are significant? It's very hard to say when do you actually want to do a full review of your security. And some teams, they just do it every 6 months, and that's kind of arbitrary, but it's at least they have something. Right? You might look at what what changes you're releasing. And then again, you have to rely on your change management, maybe Jira, right, and look at what is changing, and is this significant enough to basically do a full review of security and maybe penetration test. It's a very difficult challenge. And that's all. Thank you.